So in this video, we will begin with a new chapter, measurement and experimentation, and we will introduce ourselves to units. So let's say we want to measure the height of this man. So we will use a foot rule and we will find that the height of this man is equal to 6 times the length of this foot rule, which means that the height of the man is equal to 6 feet. So what is it that we call measurement? Measurement is the comparison of an unknown physical quantity with a known one. So in this example, the man's height was the unknown physical quantity and we compared it with a known physical quantity, that is the length of the foot rule. So the man's height is 6 times the length of the foot rule. And how do we express this measurement? For any physical quantity, the amount of physical quantity is equal to magnitude times units. So, a man's height is equal to 6 feet, the mass of an apple is equal to 400 grams, and the pendulum time period is equal to 2 seconds. Now here, the numbers are written in red and they are magnitude, and the units are written in green. So now let's understand what is it that we mean by a physical quantity. So let's say we have this yellow cube. Now we could describe this cube in terms of the length of its side, its volume, its mass, its density, its weight, or even its color, which is actually a perception of frequency. Now all these things are measurable and they are called physical quantities. And what are units? A unit is a standard measure of any physical quantity. And what is a standard measure? For example, if you look at the meter, this is the standard measure of a meter. If we measure the distance from the pole to the equator and divide this distance into 10 million equal parts, each of these parts would be equal to 1 meter. And a day? It is the time taken for the earth to complete one full rotation. And the second is a definite fraction of the day. Now for the same physical quantity, we could have different units. If I were to express my height, I would say that my height is equal to 5 feet 6 inches, or I could say that my height is equal to 167 centimeter, or I could say that my height is equal to 1.67 meter. When I express in feet and inches, I am using the FPS system. 167 centimeter is the CGS system, and when I express my height in meters, I am using the MKS system of measurement, which is also called System International. So where do these FPS, CGS, MKS come from? If we look at three quantities, length, mass and time, we find that MKS is M for meter, K for kilogram, and S for second as the units of length, mass and time respectively. Similarly, centimeter, gram and second in the CGS system, and foot, pound and second in the FPS system. So the initials of the Now there are certain quantities which we can measure directly. These quantities are called fundamental quantities. In physics, there are 7 fundamental physical quantities, and they are mass, length, time, temperature, electric current, luminous intensity, and quantity of matter. And this table consists of the SI units as well. Now, there are certain physical quantities that cannot be measured directly. In fact, to measure them, we need to conduct arithmetic operations on fundamental physical quantities. Now, such quantities are called derived quantities. Let's take the example of the area of a rectangle. The area of a rectangle is equal to length into breadth, which is why the unit of area would be equal to meter square. Similarly, speed. We know that speed is equal to distance upon time, and which is why the unit of speed is meter per second. Now certain quantities require very complex arithmetic operations, and therefore the units are named after scientists. For force, the unit is Newton. For pressure, it is Pascal. For energy, it is Joule. For power, it is Watt. For frequency, it's Hertz. For electric charge, it's Coulomb. For electrical resistance, it's Ohm. And for electromotive force, it is Volt. Now, whenever we express units, we need to follow certain conventions. So there are two conventions for unit names. We must write unit names in lowercase only, and we must never express unit names in plural. So if we have meter, meters, and meter, the first one is incorrect because the first letter is in the uppercase. The second one is incorrect because it is expressed in plural. And meter is correct because it follows the conventions for unit names. Similarly, there are conventions for unit symbols as well. We must always use correct symbols. We must never express them in plurals. And for all those units which are named after scientists, the initial letter must be in capitals. And finally, multiplication must be expressed with a dot and division as negative powers. So you do not write meter upon second, you must write meter dot second raised to minus 1. And now, the summary of this video. There are 7 fundamental quantities that can be measured directly. Derived quantities require arithmetical operations on fundamental ones. Units are standard measures of physical quantities. There are 3 systems of units: FPS, CGS, and MKS. And it is essential to follow conventions for unit names and symbols. So that's all in this video. In the next video, we will be looking at the simple pendulum.